All right, we'll work another problem. This time around, we're looking at, so it's going to be a gas stoichiometry problem again. This comes from your homework. It's number 31 from the homework. And the equation that we're looking at is water being produced from hydrogen gas and oxygen gas. And we need to balance this equation. So since oxygen's diatomic and water only has one oxygen in it, we're going to need two waters. So two waters, and then two waters would require not one molecule of hydrogen, but two. So two hydrogens for every one oxygen gets you two waters. And then the question tells us that if a particular amount, so 750 mils of oxygen at 800 millimeters of mercury and 45 degrees Celsius react with excess hydrogen, so there's plenty of hydrogen, we don't need to worry about it limiting the extent of the reaction. What is the percent yield if 0.750 grams of water are actually produced? So it's a percent yield problem. To do a percent yield problem, so percent yield is calculated by taking what is actually produced and divided by what could theoretically have been produced based on our initial conditions. And the actual amount that's produced, it tells us, is 3/4 of a gram, 0.750 grams of water. And we need to find this theoretical yield. And that we're going to do with stoichiometry. So I am going to need to find some unknown grams of H2O. So let's see. I know that there's a ton of this, so lots of H2, so I'm not concerned with that. Why is it so dull at the top? All right. So I'm not concerned with the H2, but what I am concerned with is the oxygen. And so we have, for this oxygen, it's at a pressure of 800.0 millimeters of mercury. We have a volume of 750 milliliters. It's at a temperature of 45 degrees Celsius. And then that is the extent of the information provided. So in order for me to take information about one substance and find information about another, I'm going to have moles of oxygen so that I can then find moles of hydrogen. So the problem is going to look something like this. I'm going to take all this info that they gave me about O2, and I'm going to try and find moles of O2. And then after I find moles of O2, I'm going to try and find moles of water. And after I find moles of water, this is easy for us, I'm going to take moles of water and turn that to grams of water. So from all this info they gave me about water, I need to find moles. And so PVTN, so that tells me I'm going to use the ideal gas law. R, as you recall, is 0.0821 atmosphere liters per mole Kelvin. So that means pressure needs to be in atmospheres, which it currently is not. Volume needs to be in liters, currently not. And temperature in Kelvin. So a lot of converting that needs to happen before I can work this out any further. So pressure, so it's times, it's 1 atm for every 760 millimeters of mercury. Volume, it's going to be times it's 1 liter for every 1,000 milliliters, and temperature we are going to add 273 to that. So then my pressure is going to be 1.053. My volume is going to be 0.750 liters, and my temperature is going to be, 318 Kelvin. So then if I take my ideal gas law and I rearrange it to find moles, I'm going to divide PV over to the other side. So moles is going to equal P times V over RT. So moles equals 1.053 times 0.750 divided by 0.0821 times 318. And this is all information about oxygen. So once I find this moles, it's moles of oxygen gas. So then we can plug that in our calculator. So what do we got? 1.053 times 0.750 divided by 0.0821 times 318. And we get 0.0303 moles of O2. So we are right here in our plan. And then I want to go from moles of O2 to moles of water. I'm going to do that with a mole ratio. Now I erased the balanced equation, but it was 2 moles of water for every 1 mole of oxygen. So I'm going to take this times 2 moles of water for every 1 mole of O2. And so I double that guy. And so we are looking at 0.0605 moles, or whatever, 0.0606. I kept the unrounded number in my calculator. So moles of water. And then we want to convert that to grams of water. Water is 18 grams per mole. So then I'm going to take this and I'm going to multiply by 1 mole for every 18.0 grams of H2O. And we get 1.09. So our theoretical yield was 1.09 grams of water. So if I actually got 0.750, I could have gotten 1.09. And so my percent yield is going to come out to be 68.9. So 68.9%. Should be the answer that we've got on the answer key. So sorry that was a little bit messy. So not a lot of room here on Alice.